So, lesson 1 of energy types. When I ask my students to name a load of types of energy, usually I get people to write them on bits of paper. I'd say most people can remember about 3 or 4. And why don't you pause the video, try it yourself in the back of your book, write down all the types of energy you can think of. Off you go. And assuming you didn't, you just waited for the answers. So here we go. The first one is we're going to write light. So draw a little picture of a light bulb. And the sun, which we've had quite a lot of recently. And there's the sun shining away, doing nuclear fusion, keeping us warm. So, light energy first. And when you say light, the next one then usually is sound. We think about seeing and we think about hearing. So we could draw musical notes. And we could draw a speaker. And out comes the sound, like so. Next ones. These usually come in a pair as 2. This one's called kinetic energy. And if you remember from year 7, kinetic energy, it is the energy of moving things. So if we was to draw a little car or a little van, moving objects have kinetic energy. So if you throw something while it's moving in the air, inside it is kinetic energy. And you can throw things forward, but what if you throw them upwards? Well, then you get the longest one to write, gravitational potential. Oh, not potential. Potential energy. Now, I hate writing long words out. So scientists write G, P, E. You might have remembered that from year 7. Okay, so we've had light and sound, kinetic, moving energy, and gravitational. Next, the ones that keep you alive, and that's chemical energy. Chemical energy. Now, you might see it written as chemical potential. There's that potential word again. Energy. What that means is that the energy is inside something. So when the teacher says to you, you have lots of potential, it means within you is something great that's waiting to come out. Could be you're going to be a fantastic singer, a loving parent. I don't know. Lots of potential. And for this, the gravitational energy is inside the object, so it's potential. And the chemical energy is inside the chemicals, it's potential. Next one. The one that keeps your underpants up. Elastic energy. Elastic energy, and I'm going to draw. Oh, I haven't been drawing. I've just realised I'm going to draw. Let's see if you can figure out what I'm going to draw. Like that, and I'll choose red for that. We'll draw it coming out like that and around like that. So I've drawn. I'm going to draw a stone there. Catapult. So catapults have lots of elastic energy. And so do boop, boop. Oh, that was terrible drawing. Try again. Boop. Your Y fronts. Boop, boop, keeps them up. And there's your elastic. Okay, next one. Doing these from memory, so I'm earning my money here. Magnetic. Magnetic. And magnetic energy. As we've seen before when we've had a little play with magnets, we have a north and a south. I'll just shade them in a bit. Usually north is red and south is blue. And around it, it has this thing called the magnetic field, which is like the wings of a butterfly. Out they go like that. So that's our magnetic one. Next, one of the most useful ones humans have, and that is electricity. And we've already played around with circuits, so we're used to the idea of electrical energy moving around the circuit. It can also include things like lightning, electrical energy from clouds as they hit the ground. So that's electricity. And the last one, the most abundant in the entire universe, is thermal energy. And that is from everything. Everything has thermal energy. Fires have a lot, but human beings have it. We give it off. In fact, everything has a small amount of thermal energy, even ice. And we're giving it off all the time. That's how infrared cameras work. So that's us. So altogether, we can see there that there are 9. Occasionally, we include nuclear. So we can say here, there are, and we're just going to go with 9. 9 types of energy. So copy that in your book. There's my types. Okay, now the ones that people normally have written in their book, maybe you have too. And I'm going to write them over here because these are in my not list. Let me put it over here. Maybe you've written wind. Maybe you've written solar. You might have put wave. You might have put hydro. What you've actually listed here are called sources of energy. They are all places human beings find these kind of energies to harness to make usually electricity. All right, so if you've written wind, what you've said is there is a technology called wind energy. It's a source of energy that gives us kinetic energy because it moves the blades, and that turns it into electrical energy. So I'm going to put these over at the side here. I'm showing that they're there, but they're not types of energy, they're sources of energy. All right, so if you could think of any others, they probably go in there. So far, there are 9 types of energy. Now what I'm going to do is something a little bit more. We've done this in year 7. Now we're moving on a bit further. We're going to split them into 2 categories. There are 2, and we'll call them families. Families of energy. And it's a subtle difference, but let me go with it. I want to think about kinetic energy a minute. So I'm going to grab kinetic here. Copy. I'm going to paste it here. So I've got my kinetic energy. And if I was to ask you, where is the energy? Hopefully you'd all say the energy is inside the car. If I was to take gravitational potential energy, so if I had let's do that again, GPE, so I don't know, I had a ball off the ground and I said, where is the gravitational potential energy? You'd say, what's in the ball? What about if I had elastic energy? So I'm going to grab my one here, copy it, paste it. Elastic, and I said to you, where is the elastic energy? By now, hopefully, you're all saying, yep, it's in the elastic band or the spring. So all of these have the energy in them, and so we call these stores. It means that the energy can sit inside the object. Now, if we were to take some other ones, chemical potential energy. Chemical is an energy store. Magnetic. And thermal, but there are a couple of types. I'm going to write thermal. I'm going to draw a cup of hot tea, like that. And again, if we would say, where is the energy? We'd say it's inside. Where is it on the magnet? Inside. Where is it in the chemical reaction? It's inside. So these are my energy stores. There's also one called static electricity. So when you rub a balloon against your head and it becomes sticky, it pulls your hair up, that is a form of energy called static electric. So those are stores. Now you will realise I haven't included all of them on this list, in particular light and sound. But I hear you say, well, the light bulb's got the light in it, but has it? The light immediately escapes. Sound, the speaker's got the sound, but it doesn't. The sound escapes. And what these do, these are called pathways. So I'm going to do them in blue. These are pathways. The definition for those is they link stores together. So I'll put that definition. They link stores together. So let's give it a go. Trying to think of a good example now. We will have electricity as one of them. Electricity is a pathway. What do I mean? Well, here we have the cell. Inside the cell, we have a store, in red I'll put it in. Inside the battery is chemical. Okay, then the circuit is completed, so the electricity is the flow of the current, and it goes, and it connects up through being a pathway to another, in this case another pathway, goes to the light bulb, and the light bulb turns the electrical energy into light energy and thermal energy, and it heats up the air around you. So what have we got here? That the electricity is the pathway linking the chemical energy in the cell to the light bulb, which is turning it into light and heat. So electricity is a pathway, not a store. Light is also one, light, and sound. They don't have bodies that they live inside of. So light and sound. The third and final one is called work done. Now work, when we talk about it at school, usually it means sit there, don't talk, get on with it, do some work. But work in physics means moving things. It means using your energy to get stuff done. So if I had a table there and I had an object there, heavy bag, I would do work lifting it up onto something. I would be doing work. Likewise, if my car broke down and I had to give it a push, so there's my car, which is highly likely because it's a bit rubbish. So I'm giving my car a push. I would be doing work, because I would use my energy to move that object, and that is a pathway too. It's best not to overthink it too much. Anyhow, that's it for this lesson. I will post a PDF of this as well. Hopefully you'll have copied it all down, pause it anywhere you want, and then take a photograph in your book and post it just to say you've done it. All right, fresh start for everybody. So if last time wasn't that good, fresh start. Hopefully this time it will be. Take care. Bye.